For years, the story of AI looked almost simple. You took a model, you gave it more data, more compute, more parameters, more engineering, and almost like clockwork, it got better. Bigger models wrote better text, better code, better summaries, better images, better answers. So the industry learned a lesson that felt almost magical. If you want smarter AI, just scale. Scale the training, scale the chips, scale the data centers, scale the budget. And for a while, that formula looked unstoppable. But now, something feels different. Not because AI stopped improving. It clearly hasn't. The models are still getting better. The products are still getting better. The capabilities are still growing. But the relationship between money spent and visible breakthrough is starting to change. And that may be the most important thing happening in AI right now, because it looks like we may have reached the roof of easy AI returns. Not the end of AI progress, not the end of intelligence, but the end of the phase where throwing more money at the same recipe gives you the same kind of dramatic leap. And if that's true, then the future of AI is about to become much more interesting. Because once a field hits diminishing returns, it has only two choices: keep spending more for smaller gains, or invent a new paradigm. And this is where the story gets really wild. For the first time in history, we now have AI systems that can help researchers search for the next kind of AI. Not just use AI, not just sell AI, but use AI to help research AI itself. That changes the game. Because the next era of artificial intelligence may not be built by humans alone. It may be built by humans working with AI systems to discover what comes after scaling. And that could be the moment when AI stops being just a product and becomes a tool for inventing its own successor. Let's start with the first big question. Why does it feel like AI is giving us smaller returns for bigger spending? Because for a long time, scaling was the best shortcut in the history of computing. The formula was elegant. Use more training compute, train on larger datasets, make the models bigger, refine the post-training, and the result was often obvious. But now the frontier looks different. According to Stanford's 2025 AI Index, training compute for notable models is still doubling roughly every 5 months, datasets every 8 months, and power use is still climbing. But at the same time, the gap between the best and the 10th best models narrowed sharply, and the gap between the top 2 fell to around 0.7%. That means the spending race is still intense, but the visible separation at the top is getting smaller. That's a huge signal. It means more money is still buying improvement, but it's buying less distance. And when that happens, a field starts to mature. The first gains are dramatic because the low-hanging fruit is everywhere. Later gains still matter, but they come at a higher cost, with more complexity and less obvious differentiation. That's what AI looks like now. The old formula still works, it just doesn't dominate the future the way it used to. And there are a few reasons why. The first is simple. Benchmarks are getting saturated. When top models start scoring extremely high on the old tests, the scoreboard stops being as useful as it once was. A 2026 Nature paper introducing humanity's last exam argued that many popular benchmarks had become too easy for frontier systems, noting that state-of-the-art models were already above 90% on tests like MMLU. Once that happens, small score differences stop telling you the full story of what changed. The second reason is data. The first scaling wave benefited from something rare, a giant reservoir of human-generated internet text and code. But that reservoir is not infinite. Echo AI estimated the effective stock of public human-generated text at around 300 trillion tokens, and projected that if trends continued, frontier language models could fully utilize that stock sometime between 2026 and 2032. That doesn't mean we wake up one day and run out of data, but it does mean the free lunch is ending. The easiest text has already been harvested, and the more a field depends on the same raw material, the more it starts to collide with limits. So people say, fine, we'll just use synthetic data. And yes, synthetic data will matter, But there's a catch. Nature published a widely discussed paper on model collapse, warning that when models are trained too heavily on data generated by earlier models, they can begin to forget the less common, more valuable parts of reality. In other words, if AI keeps learning mostly from AI, it can become smoother, flatter, and less grounded. So now we have a strange situation. The old scaling recipe still works. The benchmarks are saturating. The data gets trickier. The frontier gets more expensive. And the difference between top competitors gets smaller. That is exactly the kind of moment when an industry starts searching for something deeper. Not just more AI, different AI. And that brings us to the next question. If bigger models are no longer enough, what comes next? This is where the conversation gets exciting, because the next phase of AI probably won't be one giant replacement for today's systems. It will be a collection of new paradigms layered on top of the old one. Think of it like this. Transformers and large models are probably not disappearing, but they may stop being the whole story. Instead, they become the foundation for systems that can reason longer, use tools better, interact with environments, verify their own work, understand the physical world, and maybe even inspect their internal logic. In other words, the future may belong to AI systems that are not just bigger, but more strategic, more grounded, more structured, more self-correcting. The first major shift is already visible. Reasoning is becoming its own scaling law. For years, most of the focus was on pre-training. Stuff more knowledge into the weights, compress more of the world into the model. But recent reasoning-focused models changed the conversation. OpenAI said its O1 series improved not just with more training, but also with more reinforcement learning and more time spent thinking at inference. The company later said the same broad pattern held for newer reasoning models as well. More compute spent on deliberate problem-solving can improve performance in a way that is different from classic pre-training. That is a big conceptual change, because it means the path to better AI may not just be train one giant brain and hope it remembers everything. It may also be build a system that knows how to spend more thought on the hard parts. That sounds obvious when humans do it. We don't think equally hard about everything. We spend seconds on easy questions, minutes on harder ones, hours or days on the hardest ones. AI is starting to move in that direction. And once that happens, intelligence becomes less about stored prediction and more about active problem solving. That matters because the old scaling paradigm mostly answered one question: how do we make a model know more? The next paradigm asks a different question: how do we make a model think better? That is not the same problem, and it may be one of the biggest opportunities in the entire field. The second paradigm is agents and tool use. A plain language model tries to answer from what it already knows. An agentic system can search, inspect files, call software, run code, use memory, compare alternatives, and build intermediate steps. That is much closer to real work, because most valuable work in the world is not answer in one paragraph. It is search, test, revise, verify, retry, compare, document, and execute. And this is important for one reason above all. Research itself is a tool-using activity. Scientists don't just think. They search papers, write scripts, run experiments, inspect anomalies, revise hypotheses, generate charts, compare outputs, document failures. So if AI gets better at using tools, it gets better at doing pieces of research. And when AI gets better at doing pieces of research, it gets better at helping invent future AI. The third paradigm is world models and embodiment. This may be one of the underrated shifts in the field. Today's AI is still heavily optimized for language, code, and static media. But a lot of real intelligence lives somewhere else. It lives in action, in consequence, in physical interaction, in planning under uncertainty, in the ability to do something, observe what happened, and adapt. That's why world models are so important. Google DeepMind's Genie 3 was introduced as a general-purpose world model capable of generating a wide range of interactive environments. And DeepMind's Gemini robotics work framed the next step even clearer: AI systems that can understand, plan, and act in the physical world, with Gemini Robotics ER reportedly improving end-to-end robotic success rates by 2 to 3 times,
compared to Gemini 2.0 in that setup. Why does this matter so much? Because language can hide confusion. The physical world cannot. A robot either grasps the mug or drops it. A planner either avoids the obstacle or crashes. A simulated environment either teaches useful structure or it doesn't. Embodiment forces intelligence to become more honest, and that may be one of the best ways to break past the ceiling of purely text-based progress. If future AI can learn not only from language but from interactive environments, that opens a new entire path. A path where intelligence is trained not just by imitation, but by experience. The fourth paradigm is interpretability. For a long time, interpretability sounded like a side topic. Interesting, maybe important for safety, but not central to capability. That view is getting harder to defend, because once gains become marginal, understanding matters more. If you don't understand your systems, you waste time, you waste compute, you waste research cycles, and you can't reliably separate real progress from accidental tricks.
Anthropic's 2025 research on tracing the thoughts of a large language model described progress in identifying internal concepts and computational pathways inside a model, with the goal of building more of a microscope for how these systems actually work. That idea is bigger than it sounds. A microscope does not replace biology, it transforms biology. A telescope does not replace astronomy, it transforms astronomy. Interpretability could do the same for AI, because if researchers can inspect what a model is doing internally, they can debug faster, align better, compress smarter, and transfer insights more efficiently. And once AI starts helping research AI, interpretability becomes even more important. You do not want black boxes redesigning black boxes forever. At some point, the field needs instruments, ways to see inside the machine, not just scale it from the outside. The fifth paradigm is neuro-symbolic and verifiable AI. In simple terms, this means combining the flexibility of neural models with systems that can check, constrain, and prove things more rigorously. Because here is the hard truth. Current models are incredibly good at sounding correct. That is not the same as being correct. And for some domains, sounding right is not enough. Math, formal verification, scientific derivation, safety-critical planning, complex engineering. In those areas, the future may belong to systems that generate ideas creatively, but also verify them through code, logic, theorem proving, or explicit constraints. That hybrid approach may become one of the most important bridges in AI research. Not neural versus symbolic, neural plus symbolic, intuition plus proof, generation plus verification. Because once you care about truth more than style, that combination becomes extremely powerful. So those are some of the big possibilities: reasoning, agents, tool use, world models, embodiment, interpretability, hybrid verification. Different paths, but all aimed at the same conclusion. The next leap probably won't come from doing more of the exact same thing. It will come from finding a new compounding curve, a new place where progress becomes steep again. And now we reach the most important twist in the whole story, because even that search is changing. For the first time in history, we have AI that can help with the research of AI itself. That is not science fiction anymore. It's already happening in pieces. Google introduced an AI co-scientist in 2025 as a multi-agent system designed to help researchers generate novel hypotheses and research proposals, with reported examples in areas like drug repurposing and liver fibrosis target discovery. Sakana AI said its AI scientist V2 produced a paper that passed peer review at a workshop in a top machine learning conference, positioning the system as an end-to-end research agent capable of hypothesis generation, experiment design, analysis, visualization, and manuscript drafting. And DeepMind's Alpha Evolve took a different route. Instead of just writing about ideas, it directly searched for better algorithms and code changes under automated evaluation,
with reported gains in mathematical algorithms, data center scheduling, and matrix multiplication infrastructure used in Gemini training. Pause there for a second. That is an entirely different world from the one we had just a few years ago. Before, AI research was almost entirely human-led, with software as a passive tool. Now, the software is becoming an active collaborator. Not perfect, not autonomous in the grand sci-fi sense, but active. It can search, suggest, compare, code, evaluate, optimize, sometimes even surprise. And when that starts happening across multiple layers at once, the whole research engine speeds up. Think about what this means. AI can help search the literature faster, generate candidate hypotheses faster, write experimental code faster, analyze outputs faster, find patterns faster, suggest better kernels, suggest better layouts, suggest better algorithms, and in some cases, help inspect the internal behavior of models too. That means AI is no longer only the object of research, it is becoming part of the research method. That may turn out to be the biggest shift of all, because the next age of AI progress may not come from one company simply training the biggest model. It may come from research systems that help humans explore a much larger space of ideas than humans could explore alone. And that's how a field escapes diminishing returns, not by giving up, by increasing the speed of discovery. But there's a deeper reason this matters. Every major technological era eventually hits a point where brute force stops being enough. At first, scale dominates, then scale gets expensive, then the easy gains shrink, then the winners are the ones who invent a better method. That's where AI seems to be standing now, at the edge between scaling intelligence and redesigning intelligence. The first era taught us that large models can absorb staggering amounts of structure from data. The next era may teach us how to make them deliberate, verify, act, interpret, simulate, and discover. And once AI helps with that process, progress could start coming from a different source. Not just larger training runs, but faster research loops, better idea selection, better experimental experimentation, better infrastructure, better scientific instruments for understanding the models themselves. That's why this moment feels so important, because the ceiling we may be hitting is not the ceiling of intelligence, it's the ceiling of one strategy for building it. And once that becomes clear, the whole field changes. The question stops being how much bigger can we make the current model, and becomes what kind of intelligence should we build next? That's a much deeper question, and for the first time, we may have machine partners capable of helping us answer it. So where does that leave us? Probably in the most interesting transition AI has faced so far. The old formula isn't dead, scaling still works, big training runs still matter, frontier models still improve, but the era of easy returns from scaling alone looks increasingly fragile. The money goes up, the complexity goes up, the power demands go up, and the visible separation at the top gets harder to maintain. That's usually the signal that a field is ready for reinvention, and the reinvention has already started. In reasoning models, in agents, in tools, in world models, in robotics, in interpretability, in hybrid systems, in AI-generated research, in AI-designed algorithms, in AI-designed infrastructure. Piece by piece, the field is building the machinery for its next phase. And that leads to one final thought. Maybe the biggest breakthrough in AI won't be a single model release. Maybe it will be the moment when AI becomes good enough to consistently help invent better AI. The moment when the field turns recursive, when intelligence becomes one of the tools used to build the next version of intelligence. That doesn't mean humans disappear in the story. If anything, it makes human judgment more important. Because once machines can generate more ideas, run more experiments, and search more possibilities, the real bottleneck shifts towards taste, direction, verification, and wisdom. Humans still choose the questions. Humans still decide what counts as truth, value, safety, and progress. But now, for the first time, they may not have to search alone. And if that's true, then this moment in AI is not the end of the boom. It's the end of the easy phase. The next phase will be harder, more scientific, more experimental, more interdisciplinary, more uncertain, but maybe far more powerful. Because the first era of AI was about scaling models, the next era may be about using intelligence to redesign intelligence itself. And that's where things stop being merely impressive and start becoming historic.